It is formed spontaneously by static and modular nodes as and when they want to communicate with each other. Now, such a network is very much useful in the situation of natural disaster to send emergency message very quickly from one node to other node, from one location to other location. It is useful for communication among fishermen in deep sea. So these are the various important application of ad hoc network. Now, vehicular ad hoc network, so it is a type of ad hoc network. Vehicular ad hoc network is a kind of ad hoc network, but the only difference is that the nodes are vehicles. That means planet formed spontaneously by the vehicles on road as and when they want to communicate. Okay? So, the vehicles are moving at a very high speed, so definitely there are a lot of challenging issues because of the high vehicle velocity, random speed, and as the velocity of vehicle is very high and changes very rapidly, therefore it is the position of vehicle also changes rapidly. So because of this reason, there are a lot of important research issues in this area, and mainly what advantage we are getting from planet. Suppose a vehicle on move finds an event or observes an event. What is event? Event just like accident or event just like traffic jam. So as soon as a vehicle observes such an event, it generates a message, suitable message, in which it describes the event and its location and mainly broadcasts this message to the neighbor vehicles, so that the neighbor vehicles becomes aware about the occurrence of such event. So this is the reason why the vehicles wants to communicate with each other, for which they have to form vehicular ad hoc networks on the road. Now, characteristics of planet. First of all, I told you already, the vehicle velocity is high as well as random, so the position of vehicle changes rapidly. Network topology changes very frequently. The size of the network, size of planet is unbounded because it could involve vehicles in one city, several cities, or even a country. That means how many vehicles wants to communicate, how many vehicles involves in communication, that decides the size of the network. And the vehicles exchange information, that I told you, the reason of exchanging information also. Wireless communication, that means communication among vehicles is mostly wireless. So definitely all of you know the wireless communication is not reliable. So definitely it needs some security measure. The communication among vehicles is time critical also, because it is required to disseminate any emergency message related to the occurrence of any event among the other vehicles very quickly to avoid any traffic jam, to minimize the congestion on the road. And most important characteristics of vehicular ad hoc network is that it has no issue of energy, provides unlimited transmission power. Now, regarding system architecture, physical layer involves antenna modulation, spectrum allocation kind of issues. Map layer concentrates on avoiding transmission collision. Why transmission collision is there? Because the vehicles actually share a medium for communication among themselves. So as the medium is shared in nature, so there is a high possibility of collision among the different messages that are generated by the different vehicles. And the network layer issue obviously related to routing, performs functions related to traffic congestion, vehicular movement, data dissemination. Transport layer issues mainly on reliability and security. Application layer relates different types of safety applications as well as comfort, entertainment applications. This application I should discuss. Frequencies for planet, this is different for different parts of the world. So for North America it is 5.850 to 5.925 gigahertz, but the frequency for Europe is something else, 5.885 to 5.905. For Japan, they uses two range of uplink and downlink frequencies and uses amplitude shifting modulation for a data rate of 1 Mbps. Now, wireless access technology. Actually, in the wireless networking domain, diverse wireless technologies are utilized for sharing data as well as for providing data service. So, in the planet environment, cellular system actually helps to reduce the limited available frequency for the service. Wireless layer wireless fidelity provides wireless access to enable communication. WiMAX offers a wide coverage area, high data rate, and it supports quality of service issues which are suitable for multimedia applications like voice on IP. And dedicated short-range communication is a most useful protocol for short-distance communication in vehicular ad hoc network. So actually the communication between two vehicles is a short-range communication because this communication is possible as long as those two vehicles are within their communication range. That's why for such a short-range communication, DSRC protocol is very much useful. Now come to the part TANET application. So most important application of TANET is the safety applications. Okay, so actually traffic jam go on increasing with vehicles, with the number of vehicles. Traffic pollution increases. Because of traffic jam, there is a huge wastage of fuel as well as time here. So by making vehicle a little bit intelligent, it is possible to minimize traffic jam as well as pollution. Here, so future vehicles, which are the device of vehicular ad hoc network, the future vehicles will be equipped with on-board unit having storage capability, communication capability, as well as computation capability. The future vehicles will have GPS receiver to know global positioning system receiver to know their current location. They have multiple sensors to measure the parameters like speed, acceleration, distance from the neighboring vehicles. So a vehicle just sends some information. For example, suppose a vehicle detects a traffic jam in a road. Then it generates a message and sends it to its neighbors. And all those neighbor vehicles detects this traffic jam from their on-board unit. So what advantage we are getting? As soon as a vehicle detects the presence of traffic jam occurrence of traffic jam in a particular road, then that vehicle can select some alternate route to go to the destination. Clear? So which ultimately helps to minimize the traffic jam, which ultimately helps to save fuel, save time also. Clear? Now, regarding the other applications, the convenience applications is also there. A vehicle detects that a traffic jam occurs in a lane or an accident occurs in a lane from its onboard unit, then that vehicle chooses an alternate path, get an opportunity to select an alternate path. So definitely it is a convenience for that vehicle. Here it saves fuel, it saves time, and it enhances our traveling comfort, and it enhances our driving of communication, inter-vehicle communication, vehicle to roadside communication, and inter-roadside communication. So roadside communication means it is a roadside unit, the roadside unit in the planet environment, so that may be the base station also. So inter-vehicle communication is actually the communication between vehicle and vehicle. So such vehicle-to-vehicle communication is required for gathering some information related to road safety from the other vehicles. Clear? So that I discussed already. Vehicle to roadside communication. So vehicle has to communicate with the roadside unit for getting a response of some queries like nearest restaurant, nearest fuel station, like this. A vehicle is able to access internet through the roadside unit. So which means a vehicle to roadside unit or infrastructure communication. Okay. In case of say electronic toll collection system, in that case also the toll booth or toll plaza may be installed at the roadside unit, and vehicle has to communicate with the roadside unit for giving the toll. Clear? So what I want to say here, most of the planet applications are based on vehicular communication of these three categories. Here I have shown inter-roadside communication also, that means communication between the two roadside units. For example, a vehicle sends a query for query to know the traffic condition of a particular road, but that road is not the coverage area of the roadside unit that receives the query. Then that particular roadside unit can contact with the other roadside unit for getting response of such queries. So now come to the part inter-vehicle communication. So I told you already most of the planet applications are based on this communication. And so why such communication is required, that I discussed already, but here I like to discuss some limitations, some difficulties of such communication. So among the difficulties, first of all, it is unreliable. So this vehicular communication is unreliable because number one, there may be a problem of hidden node. Are you familiar with the term hidden node problem in wireless environment? In case of wireless environment, usually before starting transmission, a vehicle senses the medium, whether it is free or busy. So if it finds that the medium is free, it starts to transmit. But it may happen that some vehicle which is not within the coverage area of this vehicle that wants to transmit is go on transmitting. So that problem is called hidden node problem. Okay. So hidden node problem is there. There is a possibility of collisions also, that I told you already, as a medium is a shared medium, transmission medium is a shared medium. Channel fading problem is there. For example, if an object is there in the communication path between two vehicles, then that object may prevent the signal to reach to the proper destination. Now, second difficulty is redundancy of message. So the same event may be observed by multiple vehicles simultaneously. So all those vehicles generate message. Therefore, there is a possibility of redundant message that are generated for the same event. There is a possibility of redundant message in the planet environment. So if redundant message is there, all of you can understand what is the difficulty, the wastage of bandwidth. Same message is transmitted number of times from different vehicles. Third difficulty or third problem in this third problem of this inter-vehicle communication is broadcast strong problem. Broadcast strong problem means multiple vehicles generate message after observing an event. So the total message at any instant of time in the shared transmission medium is quite large, which creates a strong, so broadcast strong problem is there, channel potential collision problems. Number 4, multi-hop inter-vehicle communication. Multi-hop, I think all of you are familiar with the term multi-hop. So in between source and destination, there are multiple intermediate vehicles. So suppose a vehicle A wants to send a message to vehicle B, but vehicle B is not within the coverage area of vehicle A. So what the vehicle A will do, it has to go for multi-hop communication. Clear? But the difficulty is that the vehicle A, it is very difficult. Vehicle A has to find the next forwarded vehicle, but it is very difficult to get a stable next forwarded vehicle in this environment because two vehicles are in each other's communication range, within each other's communication range for a few seconds because the velocity of the vehicle is very high. Currently, suppose X is my neighbor, but within a second it may not be. So definitely it is very difficult to select the next forwarder. So need effective mechanism to remove and control these challenging problems that I discussed already. B2B communication, what is B2B communication? What I told you. But B2B communication has a few advantages. For example, first of all, it is direct communication. One vehicle communicates with other vehicle who is within the communication range, or within each other's communication range. So it is direct communication. So the amount of delay or latency is very less. One driver of a vehicle can send some warning signal to the other driver of another vehicle, using such a communication, B2B communication. Here, so this B2B communication is suitable for short and medium range communication. It is not suitable for long distance communication. It supports short messages. So I have discussed already about vehicle to V2I for infrastructure or roadside unit. So vehicle to infrastructure communication. So our vehicle need to update weather report. Our vehicle need to process some queries. Our vehicle need to send the toll like this. So for all this reason, the communication between vehicle and infrastructure is important. Now come to the part challenging issues in vehicular and of network. So first of all, it is very difficult to manage the network due to the frequent change in the network topology and channel condition. It is very difficult to control the traffic congestion and collision due to the unbounded network size and frequent partition of the network. Map design is a challenging issue that I told you already, because as the vehicles share a common medium, therefore there is a high possibility of collision. Now come to the part research issues. First of all, routing. It is required to develop efficient routing protocol because the routing protocol helps to select the route between source and destination, but that route is very much unstable because of the high velocity of vehicles and frequent network partitioning. So it is very difficult, it is very much challenging to select a stable route between source and destination. At the same time, it is required to utilize the available bandwidth in an efficient way so that a new route can be established as and when required quickly. Next is data dissemination. Data dissemination means the distribution or dissemination of messages that are generated by the vehicle after observing events among the other vehicles. So any delay in data dissemination causes injuries, even death. Therefore, it is required to disseminate data within a finite delay. Another challenge here is that any intruder or attacker should not receive the data. Data must be received by the intended receiver only. So delay should be minimized. It is required to verify the authentication of the sender. It is required to verify the authentication of the receiver. It is required to verify the authentication of the message also. So, for secure data dissemination, it is required to ensure that the data is generated by, message is generated by authentic vehicle, message is received only by the intended receivers. There should not be any delay, or the delay should be as minimum as possible. Mobility modeling, actually this is required to predict the movement pattern of vehicles. As the vehicles are moving at a very high speed, their location changes very rapidly. So mobility modeling actually defines the movement pattern of the vehicles to create random topology based on the location of the vehicles. So need to develop rich topology model different from traditional network topologies. So there is a basic difference between traditional network and the VANET. There is a basic difference between mobile ad hoc network and vehicular ad hoc network. So the basic differences are that the vehicles are moving at a high speed and their speed changes rapidly. But the vehicles in a particular road follow the same traffic roads. Vehicles in a particular road, in a particular path, follow the same traffic roads. The difficulty of energy, the limitation of energy is not there. Energy limitation is not there. So these are the differences between the traditional network topology and VANET. And here you see VANET mobility measures in miles per hour instead of meter per hour. Two vehicles remain within their communication range for a matter of seconds. So it is very difficult to design routing algorithm in such a scenario. Scalability issue, that is VANET protocols must work properly in a high vehicle density area like road and highway, as well as in a low vehicle density area, as well as in the high vehicle density area. Broadcasting, this is the main dissemination technique. So I told you already, when a vehicle observes an event, it generates message and broadcasts it for its neighbors. So advantage of broadcasting is that multiple vehicles receive the message regarding the occurrence of an event simultaneously at the same time. But the difficulty is that all those vehicles may not need that particular message. For example, if you consider the case of a highway, some vehicles are moving in the forward direction and some vehicles are moving in the backward direction. So I, within a vehicle, is interested about that event which occurs in front of my vehicle. Clear? So definitely the message generated due to the occurrence of an event are important to those vehicles which are moving towards the location of the event. Clear? So In case of broadcast scenario, a vehicle just observe the event and generate message and broadcast it. So all the vehicles which are the neighbors of those source vehicle may not need that message. Moreover, broadcast strong problem is also there that I discussed already. And the continuous broadcasting of messages degrades network performance in terms of delivery rate, delay. So it is required to design effective and cooperative broadcasting algorithm to circulate safety and routing information both in low density area as well as high density area. Then security issue. So, as the communication is mostly wireless, so it is required to take some security measure. The main function of planet, main application of planet is to improve road safety. Therefore, planet must be protected from unauthorized message injection and message alteration. So there should not be any message that are generated by unauthentic vehicles. There should not be any false message. The message generated by a vehicle should not be fabricated, should not be suppressed. So all those security issues are there. So it is required to develop a robust security solution to meet the diverse requirements of the application's reliability with minimal involvement of untrusted vehicles. So in the rest of the presentation, I'd like to concentrate on planet security because of two reasons. First of all, out of all the research issues, this security issue has got less attention so far. Secondly, I told you already, most of the planet applications are based on vehicular communication, B2B, B2I communication. So it is required to protect inter-vehicle communication from the attacker. An attacker may receive a message, put it in the buffer. Objective is to introduce delay unnecessarily. After some time, we take it from the buffer and send it. An attacker may receive a message, change the content of the message, and then send it. An attacker may generate false message like clear the road for selfish reasons. So as soon as a vehicle receives such a message, clear the road, then clear a particular road, then the receiver vehicle definitely select an alternate route and go to the destination using that alternate route. So ultimately, that particular road for which this message is generated remains free, and another vehicle can go to that road and can do anything because no reporting, no vehicles are there, no observers are there. Clear? So these are the various situations where the inter-vehicle communication is affected by the behavior of the different attackers. So, security requirements and challenges. First one is authentication. Authentication ensures that the message is generated by legitimate user. Clear? So, in the planet environment, as soon as a vehicle takes an entry, vehicle registers, at the time of registration of a vehicle in the network, it is required to verify the authentication of the vehicle. In some cases, if the vehicle is authentic, then a digital signature type of thing is allocated to that vehicle. So, if a vehicle has a valid digital signature, then that vehicle is an authentic vehicle. Clear? But definitely, an authentic vehicle may misbehave also. Okay? So, misbehaving vehicles are also there in the banned environment. So, misbehaving vehicles are the authentic vehicles, but their behavior deviates from normal standard behavior of authentic vehicles. Authorization defines the type of messages that a vehicle can read and write. It defines the actions that a vehicle can take. It defines the protocol that a vehicle can execute. Availability requirement ensures that the network is always available to the legitimate user. Information must be available to the legitimate user. Network should be available even if it is under an attack without affecting its performance. Down reputation, a vehicle sends out a message, but later the vehicle denies its transmission. Privacy requirement is very much important to protect the personal and private information of a driver. Drivers don't want their personal and private information to be accessible by others. Confidentiality is confidential communication, so only the intended receiver receive the message. Integrity requirement ensures that the data or message should not be altered during transmission. Real-time constraint is a very important requirement because such messages need dissemination at a very rapid rate. It is required to disseminate message at a very rapid rate. Most of the 60% traffic collision can be avoided if a warning signal can be sent to a driver at least half of a second before the occurrence of collision. So, you can understand the real-time constraint message should be disseminated in time. Data consistent reliability. Authentic node can perform malicious activity that I told you already. A vehicle enter into the banned, registration phase is over. Vehicle has sufficient component. Vehicle has sufficient keys or sufficient. The vehicle has a valid digital signature by which other vehicles can understand. Okay, this is an authentic vehicle, but such authentic vehicle may misbehave. Correlation among received data from different known and particular information may avoid this type of consistency. Suppose an event occurs. I being a vehicle received 100 messages and I compare those 100 messages related to that particular event and try to find out which messages are not related. Okay? So in this way, it is possible to find out there are a lot of schemes to identify the misbehaving vehicles, and as soon as a misbehaving vehicle is identified, the banned revokes such vehicle. Key distribution, actually, to ensure message integrity, the message is encrypted at the sending end and decrypted at the receiving end using same keys or different keys. So, it is required, I think all of you are familiar with encryption decryption. So, it is required to distribute such keys securely among the vehicles. And execution time of security protocol should be as small as possible due to the high mobility of vehicles. Such attackers are authentic nodes of panic. The authentic members of network are insider, and these are the misbehaving vehicles. These are the misbehaving nodes. Their activity differs from normal behavior of authentic vehicles. Outsider not authenticated for direct communication with other members of the network, so they have limited capacity to attack. Malicious attacker damage the network. Malicious attacker disturb the authentic members of the network without expecting any personal benefit. Rational attacker expects personal benefit from the attack. As it expects personal benefit, so it is predictable and it follows some pattern. Active attacker generate new signals or packets to damage the network. And passive attackers are the attackers that can access the network, can sense the channel, can go through the confidential data, but can't generate any new packet, can't modify any confidential data. So the presence of passive attacker in the network environment is less harmful. Now finally come to the part attacks in panic. So first of all, impersonate attack. It is performed by active attackers. The attacker may be insider or outsider. The attacker uses the identity of some legitimate vehicle. Attacker misuse the panic resource that is not available to it under normal circumstances. This type of attack, impersonate attack, performs in two ways. False attribute possession, that means the attacker uses some attributes of legitimate vehicles and just behaves like a legitimate vehicle. Serial attacker sends different messages to different vehicles using different identities at the same time. Creates an illusion to vehicles that there is some other additional vehicles on the road sending messages like traffic jam, because the attacker uses different identities. So it looks like the messages are coming from different vehicles. Session hijacking. The attacker controls the session between two vehicles. Usually the authentication process starts after initiating the session. So the attacker node can get an opportunity to control the session between two vehicles. Location tracking is an important issue in case of theft. The location of a vehicle at a particular time or location of a vehicle in a road actually helps to track a vehicle within the coverage area of the network. It is useful to track a misbehaving vehicle also in the network environment. Reputation, I have discussed already, attempts to deny that a vehicle involved in communication. Eavesdropping is the network layer attack. It is the attacker is passive type. Goal is to access the confidential data. Denial of service attack, DOS attack. So attacker go on sending the signals, go on sending the messages. Objective is to jam the channel. SIM flooding sends the attacker objective is to flag the buffer of a victim node. Okay, so all of you are familiar with incoming attack in network environment. So same thing is happening here also. The attacker sends a lot of SYN requests to the victim node. Victim node sends SYN acknowledgement, but the attacker does not send any acknowledgement corresponding to SYN plus ACK. So ultimate objective is to prevent the legitimate vehicle from getting access of network services. Routing attack. Attacker either drops the routing packet or disturbs the routing process. In case of black hole attack, the attacker sends a route reply for a fresh route having minimum hop count, so that the routing algorithm selects this route for transmission. As soon as such a route is selected for transmission, the attacker silently drops the packet. Receives the packet from the route, captures the packet from the route, and silently drops it. Wormhole attack. So wormhole is actually a tunnel between two adversaries. One adversary is at one end of the network, who are receiving the packets, then tunnels those packets to the other end of the network, where the other adversary is there, and from that new point of the network, the second adversary starts to replay the packets. Grey hole attack is an extension of black hole attack. So in case of grey hole attack, the malicious node drop the packet, routing packet selectively. So difference between black hole and grey hole: in case of black hole attack, the attacker may drop all the packets, but in case of grey hole attack, it drops packets selectively. Message suppression attack: attacker simply receive a message, suppress the message. Don't send the message to the next node. Don't broadcast the message for the neighbors. Fabrication attacker: attacker transmits false information into the network. Alteration attack includes delaying the transmission of the information, replay earlier transmission, or altering the actual entry of the data transmitted. Replay attack: attacker replay the transmission of an earlier information to take advantage of the situation of the message at time of sending. Then conclusions. So I like to conclude: vehicles can communicate with the other vehicles. Vehicles can communicate with the roadside to improve the road safety. So all these are required in the future intelligent transportation system also. Communication services enable a wide range of applications: road safety, driving comfort, entertainment, infotainment. So all the research issues of planet must be addressed carefully so that it can be deployed in future. These are the references.
Question. Madam, what is the difference between the message suppression and the black hole attack?
Message suppression and black hole attack. Actually, black hole attack is related to routing. So a route is selected between source and destination. Some particular packets that are related to that, for which that route is selected, is going through this route. So the attacker drops the packets. But in case of suppression, message suppression, that message is random actually. It can receive message from any vehicle. It can receive message from any intruder.
Still it drops the packet, irrespective of any.
Madam, in general, what is the coverage area for a single planet?
Coverage area of a
Single vehicular approximate.
So it depends upon the protocol that is used. It can base up if we use DSRC, dedicated short range communication, then per base station the coverage area is 1000 meter. It is 300 meter to 1000 meter. So how many base stations are there within the coverage area of the network over the
Another question is that is there any specification for India for the direct communication?
DSRC is used and the frequency that I discussed for DSRC. So actually the bandwidth for DSRC is 10 megahertz. That 10 megahertz bandwidth is divided into 7 channels in case of DSRC. One channel is used for sending control. One channel is used for sending control signals. So in the panic environment, actually, in the panic environment, a vehicle sends beacon type of messages to the neighbors also. In the beacon message, it specifies its own velocity, speed, location, direction. So it depends which informations are available in the beacon. So mostly it contains the information related to the vehicle's current location and speed. Okay, so these are emergency message, beacon message. These can be transmitted using control channel, and service channel can be used for the other transmission of other warning messages.
Ma'am, can it possible to have a deadlock situation? For example, X is a vehicle, is a node, and Y is a neighboring node, and I am depending on X to get information of the status of the traffic from Y, and both of us are really dependent on Z. And Z in turn depends on X and Y, because suppose he is coming into the opposite direction. So can it put a deadlock situation where I am want my status from Z, and in turn
deadlock in terms of message. I am not getting a message. Though there is some important message.
Yes.
Very much useful to me.
Yes.
That may be due to the DOS attack. So channel is occupied,
deadlock,
or lot of collisions are there. So I am not receiving any message. So that is.
Thank you.